All right, here we go. Measurements of rotation. I think you guys are well accustomed to uh, degrees, but it's radians that you guys having issues with. And don't worry, we're gonna go slow. Yeah. So let's see how we do. So it says definition: standard position of an angle. An angle is the standard position in Cartesian coordinate system if. So don't worry, Cartesian is the same thing as rectangular, which just means x comma y. So two-dimensional coordinate grid, x and y. Its vertex is at the origin. Its initial side is along a positive horizontal axis. It is measured counterclockwise from the positive horizontal axis if the angle measure is positive, and clockwise from the positive horizontal axis if the angle measure is negative. What does all that mean? It means this. You have a grid, x-axis, y-axis. You always start on the positive x-axis. So here it is. I start there. And here's my ray. And I'm just gonna give it some random degree. I'm gonna say that's 45 degrees. So there it is. If I go counterclockwise, it's 45 degrees. And if you go clockwise, this says that it's gonna be a measure that is negative. So if I go clockwise, here it is. So you always start at the positive x-axis or horizontal axis. And so that would be a negative 45 degrees. And there it is. Is that making sense to you guys? Okay. Before it says, all right, Cardinals, one revolution is how many radians? So let's not even talk about radians just yet. Let's talk about degrees. So the positive x-axis is the reference point. So I'm going to say 0 degrees. And then the y-axis is 90 degrees from that 0 axis, from the positive x-axis. So that's 90 degrees. And then the negative x-axis is 180 degrees. And then the negative y-axis is 270 degrees. And then once you've done a full revolution, that is 360. So there it is. That's one revolution right there. So that would be 360 degrees. Are we okay so far? Yes. Okay, nothing crazy, right? Okay. In one revolution, how many degrees are there? Perfect. Yep. Have any of you been to test prep or, I don't know, math prep or whatever, maybe summer prep? Do you guys know what one revolution is in radians? It's okay. Okay. One revolution in radians. Do you remember what one circumference is in a circle? What's the formula? What is it? Do you remember? Yeah, give me the formula though. Circumference equals 2 pi r, where that r stands for radius, right? One revolution is 2 pi radians, and radians is the literal whatever the radius is. It comes from circumference of a circle. So you do know what one revolution is in radians. A radian is unitless unless they tell you what the radius is, like they tell you the units, inches, feet, meters, whatever it may be. So there you go. So you guys do know one revolution is 2 pi radians. Cool or not cool? So just like we did right now, the x-axis, like how we did how we labeled the x-axis and y-axis in degrees. Sorry, those little, bless you. We're gonna do the same thing with radians. Radians does not have the degree symbol on the top, so it's just like that. So that's just 0. That's 0 radians. So then at 90 degrees, this is pi over 2 radians. You can also say half pi. And then at 180 degrees, that is pi radians. And then at 270 degrees, that is 3 pi over 2 radians. And then one revolution, 2 pi radians. So here it is, one revolution right there. That is 2 pi radians. In case you're wondering, that Greek letter is a theta. This is a theta. This is a phi. Alpha. You don't have to know them all. Omega. Those are the main ones that we use. We usually use that to indicate some type of angle. So that's how we're measuring, guys, angles. It could be in degrees, it can be in radians. So an example, just like we did over here with the 45 degrees, I'm gonna do the same angle, really, pi over 4. So if I go like this, I'm gonna say that's pi over 4. Pi over 4 is right smack in the middle between 0 and half a pi, 1/4 pi. And if I go to quadrant 4, start in the positive x-axis, and I go this way like that, there's my ray, I'm gonna say that's a negative pi over 4, because I went clockwise. Anything crazy? Is this new stuff for you guys, or did you guys already know all this? Okay. So that's good. That's good. I wanted to make sure that we're all in the same. Because if we would have started with algebra, everyone's in a different place. But with this, we're all of us are in the same boat. That's good. All right. Coterminal. We're going to hit you with a few vocabularies, but it's not even extreme vocabulary, so relax. It says coterminal angles. It says two angles in standard position are coterminal if and only if the radian measures differ by a multiple of 2 pi. That is, phi and theta are coterminal if and only if, and then we got a formula there. Relax. We're going to talk to you about what this is. Where n stands for an integer. Why this formula though? What about in degrees? Okay, so let's talk. So don't freak out. A coterminal just means that I want the same ray. So, Chav, what are you talking about? So you guys probably are more comfortable with degrees. So I'll start off with degrees. So if I have this angle here at 30 degrees, so here it is. So that's at 30 degrees. And I go a full revolution like this, and I go another 30 degrees out. So this angle right there, that is 390 degrees. Now slow down. This angle here and this angle here are said to be coterminal. Why? Why are they coterminal? Because it's the same ray. Check it out. If I come here and I do that same degrees, see how it creates that same ray? So those are called coterminal angles. It creates that same ray, and okay, I'll slow down because I see some of you guys writing. But tell me if something's going on in your head that doesn't make sense. Everything okay so far? Okay. This is the formula for radians. Can you explain it a little slower? Yeah. So if I were to do one revolution is 360 degrees, right? Yes. If I do one revolution and I go plus 30, I would be at exactly that same. Oh, I get you. That same way. Okay. So that 390 and 30 degrees is the same. Does that make sense? Okay. No, always stop me. I'm here for you guys. So please, thank you for having the courage to guys stop me. I can't read your mind. Sometimes I can read your faces, but I don't know you guys. I've just known you guys for a week. So by the end of the semester, I'll be able to tell like what your face means. If you're like, sometimes I can tell it's obvious when you're doing this, and you just stop writing and you're just looking. Then yeah, I know that's universal. I know that everyone's lost, but that's not the case right now. Okay. Yeah. This is the formula in radians. What do you think the formula is in degrees? Phi equals theta plus minus 360 degree with a little n. Where n stands for how many revolutions you've done. It's an integer. Where n is an integer. So if you've done 2 revolutions, if you're right here at 30, and you've done 2 revolutions, you're going to add 360 to 70, you're going to add 720 degrees to that 30, and that's going to be coterminal angles. Does that make sense? Yeah. If you were to go clockwise, negative 360, 30 minus 360, what's that? Negative 330. So this rate here is the same as negative 330 degrees. If I would have done, I'll do it over here so you guys can see it. If I would have gone right here, let me choose a color black. If I would have gone boom like that, look, I went clockwise. That is a negative 330 degrees. See? So negative 330 degrees, 390, and 30 are all coterminal because they all make that same ray. What's up?
Wait, so you said the one that's in black is the formula in radians, but what is the one in blue?
The formula in degrees.
Formula in degrees.
Yeah, this and this. Yeah. But don't be a robot. This is how we become the robots. We just memorize formulas. Where did that 360 come from? If you do one revolution from that ray, you're back at that same ray. Where does that 2 pi come from? In radians, 2 pi is 1 revolution. And if I do 1 revolution in radians, I'm still in the same location. So don't be a robot, guys. Those formulas come from somewhere. I see you. So don't be a robot and just memorize those formulas blindly. Make sure you use logic to see where everything came from. What's up, Wimberly?
In the radians formula, is the 0 with the line through the same as the theta one?
This is called phi. It's just a variable. And this is called theta. I think I put them in here. Yeah, it's just letting you know that whatever your original angle, 30 plus or minus, or this is radians, pi over 4 plus or minus 2 pi. So all those are coterminal angles.
So would the original 30 degrees be theta?
Yes.
Would be in the place of theta?
Mm-hmm.
Okay.
Mm-hmm. if they were to tell you, give me all the coterminal angles, like 30 plus minus 360n, will give you all the possible coterminal angles that create that same rate. We good? Yeah, I can't read minds, guys. I mean, I don't know. Sometimes I see you guys and I think you guys are mad because you guys are like this. Like, don't be mad, guys. I'm just, let's just learn some math. I think this is cool. You don't think this is cool stuff? Yeah, this is real cool stuff, guys. This you're starting to. Okay. How does your cell phone work? How does these lights work? They're all signals, and all these signals are just waves, electromagnetic waves. Have you heard of those story about you put your car on the railroad and the ghosts push it over? It's not ghosts, guys. It's an electromagnetic wave. A car is made out of mainly metal. You got two metal beams. All you got to do is have a current going through one of them, and you create a very strong magnet. And since a car is made out of metal, that could be one of the explanations. Another one could be like it's an illusion and it's really not uphill, it's downhill. Supposedly that's one. What's up?
That's not my house. And it's just a downhill.
Yeah, it's so that one's the one with the downhill, right? So it's actually going downhill than uphill. Yeah, so it could be that too. There's many explanations, but one of them could be magnetic wave, So test all the railroad tracks and see which one has that. Okay, there's a lot. Before now, there's an app to unlock your car. But before there was an app, like if your phone has a high enough bandwidth that doesn't have filters that blocks the frequencies, you could push unlock through a landline phone that has very little noise, and that frequency will carry on, and then have your cell phone go to the sweet spot, and it would unlock your car. Because it's just a wave that you can't hear, right? That's all it is when you push the unlock button on your car. It's just a very, very high frequency that you can't hear. Maybe a bat can hear it. Well, bats can probably hear the brake waves, but I don't even think bats can hear it because it's way too. But okay, I'll stop talking. If you ever have an oscilloscope, when you hit the university, because oscilloscopes are pretty expensive. When you hit the university, check out, go near the oscilloscope, probe all the little things, all the little gizmos, push lock and unlock. Those lock and unlocks, if there's someone out there in the parking lot with an oscilloscope, they can copy that signal. And then as soon as you go inside, they can just unlock your door because they have it right. They recorded the signal. That's how they're stealing your cars in the parking lot. There's someone out there just recording. And then what do people do? As soon as you close the door, you push lock, right? Well, if you push the unlock, they're going to have that code, that unlock code. So it's better if you have a way to lock your car without pushing that button. I think that's the most safe. Of course, when you're rushing, you just forget and you just push lock. But look at all these little things that we don't even. Okay. You guys know what I'm talking about or no? Okay. All right. So whenever you get a chance, Google oscilloscope and see if you can find one, a cheap one. Did I even spell that right? Oscilloscope. Google that and see if you can find a cheap one. And who knows, maybe we can mess around with it here. All right. Let's see. What are we talking about now? I think we're good with that. I don't think we have any issues with that. Reference angle. Okay. It says here, let's see. Ms. Alcala, is it okay with you if you read this for us? Relax. It's not high stakes.
The reference angle of an angle in standard position is the positive acute angle between the horizontal axis and the terminal side.
Terminal side just means where it terminates, so that means the ray. I'm going to put the ray. I don't know, Yanni, that's a demerit. That's a joke, miss. Highlight positive acute angle, horizontal axis, and terminal side. So that means this is considered a reference angle. So let me go ahead and do our first example. So I'm going to exaggerate this. I'm going to say this is 130 degrees. Our reference angle is this guy right here in blue, theta r. What do you think that is?
50 degrees.
Yeah, 180 minus 130. It's always with respect to the horizontal axis, always. So if I have something like this, so I'm going to say that this angle is, I'm going to say that angle is 200. Our reference angle is going to be this guy right here. And that's going to be 20 degrees. It's always with respect to the horizontal. Yes, miss.
What are you writing next to the theta and blue? For the 50 degrees? Is it theta and something else? Or is that
theta r. So that's a subscript. R for a reference.
Okay.
Yeah, please stop me because sometimes I just do stuff. Are we okay so far, guys? Okay, so check this out. We're going to go slow, and hopefully we'll see some patterns. You guys ready? So we're gonna set, it says sketch angles of 71, 133, 254, and 317 in standard position. That just means to do it and calculate the measure of each reference angle. So standard position just means normal, which all these are considered normal standard position from the origin. All right, here we go, 71 degrees. So I'm exaggerating quadrant 1. There's my ray, and I'm gonna say that is 71 degrees. And the reference angle in quadrant 1 is always the same. So I'm gonna use burnt orange for reference. Theta R, 71 degrees. Notice I did not put an arrowhead on the reference angle. I just said that this measures 71 degrees. I put an arrowhead on the theta because I start on the positive x-axis and it goes, and that's 71 degrees right there. Does that make sense? Ask me, miss.
I was just waiting.
Okay, sorry. So notice there's no arrowhead on the orange, guys. So in case, Chav, what are you talking about? Ask me, Miss Yushnitz. Did I say that right? Yushnitz?
The orange line or angle, the orange angle is the reference angle for 71?
Yes. In quadrant 1, it's already acute. And here's a positive horizontal axis. And I don't want to put arrowheads on this because in a little bit I'm going to be doing negative angles. And I noticed in the past it would put arrowheads like, oh, but this is how you count, so it's negative. So I don't put any arrowheads on this. I just say the gap between here and here is just 71 degrees. Don't worry, we're gonna do some more.
Wait, can you go back up to the top real quick?
Yes.
So for the 130 degrees, the reference angle is the 50 degrees?
Yes.
Okay.
It's a gap from here and here.
Okay. And the bottom one is 71 degrees. Is still just 71 degrees as the reference angle?
Yes, because I'm in quadrant 1.
Okay.
If remember, the reference angle is always acute.
Okay.
In case you're wondering, like, why couldn't my reference angle be 130 on this one? Well, it has to be acute with reference to the horizontal axis. So here it is. That is my reference angle. It is going to be super important in physics when you start doing forces.
Okay.
Are you okay? Or tell me what's going on in that brain.
No, I was just confused why it was the same number, but I get it now.
Because you're in quadrant 1 and everything in quadrant 1 is already acute.
So reference angle always has to be acute. So like if you're in quadrant, which one would
Quadrant 2?
Quadrant 2, like you would go based off of that line.
If you always fall in quadrant 2, you're always going to do 180 minus whatever that angle is. Because your reference angle always has to be acute.
And then in quadrant 1, it will just always be the same.
Correct.
Okay,
And in quadrant 3, it's going to be whatever your angle is minus 180. You'll see right now in a little bit when we do it.
So for a case with like the if the ray was like at 90 degrees, since you can't, there wouldn't be an acute angle.
No. Yeah, I mean, at 90 degrees, that's such a special case. Like you're only going in the y direction that we wouldn't even call that a reference. We just like, that's just 90. You know what I mean? Okay. You guys ready for the next? Okay, check it out. 133. What quadrant am I in? So here I am. I'm going to exaggerate quadrant 2. And I'm going to write 133 right here. So I'm going to go, here's 133. And I'm trying to go slow. Are we still okay, guys? This right here in blue is your reference angle. And see what that is, 33. 43, 53, 63, 73. So that is 40, is it 47? So 47, I'm going to put theta R. Do you see how we're doing it?
Yeah.
Okay. Okay, here we go. I'm going to do 254. 254 is in what quadrant? 3, because it's between 180 and 270. So here we go. I'm going to exaggerate quadrant 3. Here's how I exaggerate quadrant 3. And I'm going to go, bam, like that. See? Theta equals 254 degrees. And I'll slow down. The reference angle is this one. All right, Ms. Yoshnitz, no pressure. This is, relax. What do you think that reference angle is? And you can use your buddies. The angle in purple, I'll help you. I mean, I should have put an arrowhead, right? So I'm sorry. Here's my arrowhead. There we go. The angle in purple is 254. So from here all the way to here was 254. Remember, from here to here is 180. So what do you think that gap is?
Wait, can you repeat that?
Yes, yes. Let me use my little ray here, my little laser. From here, the positive x-axis, all the way to here, that is 254 degrees. From here to the negative x-axis, that's 180. So what do you think this gap is? You can also tell me the rules, like what do I got to do?
Would you subtract
Yeah.
254 minus 180?
Perfect. 254 minus 180. So let's see what that is. 54, 64, 74. I have to do it in pieces. So 74 degrees. Yeah. In case you're wondering, don't worry, I see you. In case you're wondering about the arithmetic of how I do it, and I'm not saying that I'm the best at this. I look at this gap and I see, let's see, the difference between 254 and 200 is 54, and then I just add another 20 because the difference between 180 and 200 is 20. So 54, 64, 74. That's how I do it in my brain. I got to do it in pieces. What's going on? Don't tell me your name. Is your last name Garcia?
Yes.
Okay. What's up, Ms. Garcia?
So for this one that we're on, how come like we did the part? Like I know for the last one we did kind of like what the empty space was for the reference angle. How come we didn't do the empty space?
Because this time we're in quadrant 3, so we passed the 180. In this one, we weren't quite there at the 180. We just went bam like this. So we did that line right there. So let me write it right here. That line right here, this is 180 degrees right there from here to here like that. That's 180. So I went 180 minus that 133, gave me that 47. On this one, we had to go past the 180, so it's like, not really, we don't have that empty space. I mean, I guess this is empty space, but remember, the reference angle is always with the horizontal axis, never the vertical axis. Why the horizontal? Because, because since we walk on, we walk on a flat plane, so it's easier for us to reference the flat plane. So that's why in physics, later on, when you start doing forces, with physics, you're going to talk about the tangent force, the normal force, you're going to be referencing the horizontal. Do we have any seniors here in this class? Okay, did you remember this from physics? Okay, so hopefully you see how it's all tied apart. See, if you would have had this, it would have beasted you. Okay. Cool or not cool, guys? Okay, good. Are we getting good stuff? Okay, we're not tired yet, right? Okay. Usually math after lunch is brutal, but and I know, guys, so I'm trying not to be so brutal here. So 317 degrees. So that's bigger than 270, but not quite a whole revolution, 360. So what quadrant am I in? Quadrant 4. So I'm going to exaggerate quadrant 4. There's quadrant 4. And I'm going to go bam. And I'm not saying this is drawn to scale. Probably not. 317 degrees. So now I need to know what this gap is because that's my reference angle. Look how close you are to 360. So all we're going to do is we're going to count 360 minus 317. So I just do it in pieces, guys. So 17, 27, 37, 47, 57. So 57 and another 3 to complete. So that's 43 degrees. I always mess up, so let me know. Does that make sense to you guys? Okay, there it is. We just did it. Now, can we do that with radians? We'll find out in a little bit, but we'll go slow. How do we feel? And I should be putting arrowheads on that, so sorry, guys. I don't put arrowheads on the theta r's because that's just that gap, what that gap is. All right, it says example 2. This is coming from Delta Math. We don't have Delta Math assignment today, but you will next time. And you'll see this, you'll reference this notes here. Guys, by the way, about your notebooks or binders, only carry a binder if you're going to reference your notes. If you're never going to reference your notes, then what's the point of having a binder? So you do what you think is best for you. But my best students so far, okay, I was looking for my binder. My best students, the ones who have performed the best, not all of them, but the majority of them have a big binder and have like a little notebook where they just put random little notes and problems that give them issues from Delta and UH. We haven't done UH yet, but we'll see. All right, find an angle in each quadrant with a common reference angle with 204. So first, let's do that. It wants to know between 0 and 360. So first, let's do that. So 204 degrees. What quadrant is 204 in? 3. So I'm gonna exaggerate quadrant 3. And I'm going to say, here's 204. Theta equals 204. Put a little degree symbol. And the reference angle is this guy right there. Theta r. All right. Here's 180, the negative horizontal axis, x-axis. So the difference between 204 and 180 is 24. So my reference angle is 24 degrees. And that's it. Well, that's it for that one. It wants find an angle in each quadrant. Okay, in quadrant 1, if my reference angle is 24 degrees, my angle is 24 degrees. So there it is. Theta equals 24 degrees. Theta R is just 24. Are we okay? In quadrant 2, here's 24 degrees. I want to know what this angle is. What do you think that angle is? Subtract 24 from, so let's see, 180, 170, 160, so 156. Perfect. Do you see how we did it? And do we understand the question? Because that's really the big thing. They want to know, so first they want to know what the reference angle is. And then they say, okay, give me the angle in each quadrant where the reference angle is 24 degrees. So in quadrant 1, it's 24 degrees. In quadrant 2, it's 156. 156 will give you a reference angle of 24 degrees. In quadrant 3, it was already given. So I'm going to write quadrant 3 given 204 degrees. And in quadrant 4, exaggerate quadrant 4, here is 24 degrees. And here we go. Bam. So 360 minus 24. Is it 336? There you go. How do we feel, guys? Okay. Are we understanding it? Like we're not being robots, like we really got it, right? Okay. All right. Here we go. Let's go to the next page. And don't worry, we'll go slow. Here's our first use of a calculator if we need one. Don't worry, I'm going to use Desmos. It says sketch an angle of 4,897 degrees in standard position and calculate the measure of the reference angle. You could, if you wanted, I have seen a long time ago when I taught at Southside High School, he was actually a very sharp kid, but one of my boys did these questions the hard way. He kept going. He kept like 360, 720, and I was like, weren't you here when we did this? Like, no, I was absent. Like, oh yeah, there was a football game and he was out. And he did those questions like that, which is fine, but there's an easier way. They want to know where that is in standard position. That just means coming from the origin and calculate the reference angle. So what you're going to do, you're going to take the 4897 and you're going to divide by 360 because that's going to tell us how many revolutions it did. Does that make sense? So I'm going to go to Desmos. And then a little bit, I did it this morning in Desmos. I wasn't 100% satisfied with it. We did it with a calculator called NumWorks. I'll show you in a little bit. So here it is. I take 4897, and I divide by 360. And I get this number, 13.602777778. So this means that I did 13 revolutions and 0.602. What does that 0.602 mean? What does it mean? Take a guess.
Is it the remaining degrees?
Kind of. But how many degrees? I mean, it is related to how many degrees. Okay, let me give you an example, a real world example. If someone tells you we're going to meet in 1.5 hours, what does that mean? An hour and 30 minutes. That 0.5 means half an hour, which you calculate to be 30 minutes, right? So guys, make sure that you're not a robot. So that 0.602 means 60% of a revolution, just like the 0.5 means half of an hour. It's a percentage. Does that make sense? Yes. So I took this. So I told Desmos, I went copy paste. I went copy, Control C, and then I went paste, and then I subtracted the 13 to get this number, and I went copy because it is a percentage, and I went paste, and then I went times 360 to see what my degree is. Let's see right there. Times 360, and I didn't like that. It's almost perfect, but see how it says 217.000000008? It's 217. And I was like, okay, how can we make it where it's perfect? And I decided to use NumWorks. Have you guys ever used this calculator, NumWorks calculator? It's so good. I like it a lot. You don't have to buy the actual calculator. You can it says use it online, so you'll use it online. And then it says full screen. I just push full screen. And by the way, this calculator is a little cheaper than the TI-84. I still like the well, okay, we'll talk about that later, and then I'll go off on a tangent. I'm going to push enter. And what was the degrees again? What was it, 4897?
Yes.
4897, and I'm going to divide that by 360. And I push enter or exe, and then I get this, and I'm going to go push minus, let me see, I'm going to scroll up. That enter, I wanted to put that minus 13, so let me, how do I go back? Is it this one? Clear, there we go. That minus 13, so I can just get the little decimal there, but not the rounded one, like the one that, see how it says approximate? So I'm assuming that it's being saved in some type of register. Register is the word they use for memory, at least back then. I don't know. Maybe they changed the words now. I'm going to push times. It says, see how it says ANS? So that's the value that's saved in the register. And I'm going to put times 360. And then look, this one does not have decimals. It just says approximately 217. You know how much programming it takes to get it to do that? I bet you the code for that is like super long. You guys aren't impressed, right? You guys are like, whatever. Guys, that took a lot. I think this is how it should have been. 217. I wish decimal would have just given me 217, but that's fine. So 13.602 ... goes on forever. Then take the 0.602 and then multiply it by 360, and then you'll get 217 degrees. So 217 degrees, what quadrant is that in? 3. So I'm going to go bam, like that. There it is. I'm going to say that's 217 degrees. I'm going to go in blue, and I'm going to write theta r. What is my reference? Is it 37 or 47? 37. I was about to put 47. 17, 27, 37. Yep, 37 degrees. And there it is. Is that all they wanted? Then I calculate the measure of the reference. So yeah, that's all they wanted.
Wait, just to clarify.
Yeah.
37 degrees. How do you what steps did you take?
Well, first I did this, and I got 13.602. So 13 revolutions to 0.602 of a revolution. I took the 0.602 because that's a percentage, and I multiplied it by 360, and I got 217. So 217 degrees means that's where this. It does all, that's from 4897, spins 13 times, and ends right there.
Right.
And now I took that 217, and I wanted to figure out what the reference angle is. I know that the negative x-axis is 180, so I did 217 minus 180. And I got that 37.
Okay.
You know what I mean? No, hit me, miss, hit me. And guys, as far as calculators, you do not have to buy a calculator. You do not. I recommend, and this is just what I recommend, and I'll tell you why. I really like, there's a new calculator. The TI-84 Evo is a brand new calculator that just got, but there's a TI-84 called CE, TI-84 CE, and that one's on sale also. Probably about $20 cheaper than this if you want to get that one too. They're both about the same, but this one has the updated operating system. See? Looks nice and pretty. Kind of looks like the number, so it's okay. Nothing happened to it. It's just a piece of a machine. It's not going to break. I like the TI-84 Evo the best, or the TI-84 CE the best, because it doesn't have a drop-down menu. And the TI Inspire, don't get me wrong, if you already purchased the TI Inspire, stay with the Inspire. But the TI Inspire, for me, anytime I'm taking a test or doing something, the drop-down menu slows me down. If it's significant, I don't know, maybe not. If you do 30 questions, 40 questions in Inspire, I think it starts adding up. But with the TI-84, you have to push 3 buttons to graph on an Inspire. With this one, you just push one. You just push y equals, and you're there. And then type in whatever. If you know the shortcuts for the Inspire, well, then maybe you'll be just as fast. Okay, sorry guys that I go off on tangents. I hope that you guys are okay with that. Let me know if you're not, and I'll stop. Okay, are we still okay? Okay, so here we go. Now we got radians. It says convert the radians into degrees. So here's the hack. Don't worry, we'll be fine. Remember that we said in 1 revolution, that's 360 degrees. And then we said in 1 revolution, that's also 2 pi radians. We got that from a circumference of a circle. Circumference is 2 pi r. Are we still okay? You could, if you wanted to, use that scale factor of 2 pi to 360. But why would you want to use that when there's an easier one? Look, this one right here is 180 degrees, which is also pi radians. So it's easier to use the pi over 180 than the than the 360 over 2 pi. Chav, what are you talking about? If you wanted to, you could do this. You could say, let's see, what do I want? Pi over, don't write this down because this is the long way. We're not going to ever do it like this. You could say pi over 3 is to 2 pi as 360 degrees is to x. And you can do cross multiply, divide, and you'll get an answer. You would. Let's see, what is this? X equals 360 times pi over 3 divided by 2 pi. If you type that in the calculator, it would give you an answer. I'm just going to do it just to be silly here. I don't want you guys to do it that way because, it would take forever. I already forgot what I wrote. What did I write? 360 times pi over 3. So look, 360 parentheses pi over 3. And then get out of there. Where do I have arrows? Close. And then all this divided by 2 pi. 2 pi. Execute. See, it would tell you the answer, 60 degrees. But look how much work that took. Yeah, look how much work that took. Do it like this. Don't worry. We'll catch you up. We'll catch you up. All right. Don't worry. We will. I promise we'll catch you up. And I want to go to heaven, so I already promised. So that means we're going to catch you up for sure. You see that 180 over pi? Do it like this. You're going to go pi over 3 times, and I want to convert this to degrees, so I'm going to go times 180 over pi. And now the pi's cancel out, and then look, how many times does 3 go into 18? So this must be 60 degrees, because that's not 18, that's 180. So pi over 3 is 60 degrees. And you just saw how we did it with a calculator, and we also got 60 degrees. This one was 60. Okay, now you can write. Okay, then let's catch you up. Where were you at? Don't worry, right? And then and we'll talk wherever I come. Okay. We got like 13 point something. Yeah, that means 13 revolutions and 602 percentage of a revolution. You can take that number and multiply by 360, and that will give you the angle where you're at. I'm sure she can explain all that.
Wait, so do we write all this?
No, I would just write this one. All right, don't worry. I'm gonna give you. I know what you guys want. You guys want to give me directions. You guys are so good. Okay, and I mean this with love, so don't get mad. You guys can trick your math teacher into knowing that you guys know the material. But then when we ask you, like, why'd you do that? You guys are like, well, I don't know. I'm looking at this and you did that here, so I'm just doing that here. But I don't know why I'm doing it. I'm just doing it. You guys can follow directions like no one's business. But guys, your memory will fail you. Maybe you'll just know it for the next exam, the next unit exam. But what happens a year from now, 2 years from now? Because math builds on itself. If you want to continue going up the ladder for math, you got to know what you're doing. Like, you got to know like how everything's linked. So try really hard not to be a robot. All right, so what do we do? So when you're going from radians to degrees, so I'm going to write radians to degrees. You're going to take your radian, and multiply by 180 over pi. 4 degrees. There you go. That's kind of like your scale factor, like your conversion factor. So here we go. I'm going to take the 2 pi over 3. So I'll put it right here. 2 pi over 3 times 180 over pi. Pi's cancel out. 3 goes into 18 6 times, and 6 times 2 is 12. So just add a 0. So 2 pi over 3 is 120 degrees. Do you see how we're doing it, guys? 4 pi over 3 times 180 over pi. Pi's cancel out. 3 goes into 6. I see the 3 in the bottom. I see the 180 in the top. 3 goes into 18 6 times. 6 times 4 is 24. So this must be 240 degrees. Okay. And then 5 pi over 3. I'll write the 5 pi over 3 here. 5 pi over 3 times 180 over pi. 3 goes into 18 6 times. 6 times 5 is, so this must be 300 degrees. Are we okay? Last one, 11 pi over 6. 11 pi over 6 times, and I know, I'm sorry that I wrote it all over the place. I'm not usually like that, but I did this time. 11 pi over 6 times 180 over pi. Pi's cancel out. 6 goes into 18 3 times. 11 times 3. 33, put a 0 for 330, because it's 180, not 18. So there it is, 330 degrees. We got them all. So when you're going from radians to degrees, what do you do?
Multiply by 180 over pi.
There you go. There you go. When you're going from degrees to radians, you can say divide by 180 over pi, which is the same thing as multiplying by pi over 180. Should I put that already down somewhere? Okay, I'll put it in black. If I'm going from degrees to radians, take degree and multiply. You could also say divide by the same thing, 180 over pi. But if I put multiply, I'm going to put multiply by pi over 180 for radians. If possible, leave the pi alone so you can have it in terms of pi. We'll talk about that as we get more advanced. What time is it? 1:45. We still got time. Are we okay? Okay. Here we go. Don't worry, guys. We're almost done. We're almost done. The reason why this feels long is because we had a speech on Friday, and so I had to push that Friday stuff into today's stuff. But we're almost there. We just got a page and a half. We used to take the SAT Level 1 Math Subject Exam. We no longer take it. So here it is. What if my rating does not have a pi in it? On the SAT Level 1 Math Subject Exam, there was a question that said, convert the angle 2.5 radians. This is in the practice. Radians to degrees, round to the nearest tenth. So I take my 2.5 radians, and I'm going to multiply this by, what does it say here? Yeah, radians 180 over pi. And this one, just go verbatim with that. So 2.5 times 180 over pi. 2.5 times 180 over pi. I really like this calculator, by the way. 143.239. Now it says to do it to the nearest tenth. So 143.2 degrees. There it is. Are we okay so far, guys?
Yes.
Okay. All right. Good job, guys. Last page. Sketch angles of power 3, 2 power 3, 4 power 3, 5 power 3, and 11 power 6 in standard position, and calculate the measure of each reference angle, just like before. So before I do anything, look, here it is. I like to do this to help you guys out. That's 0. That's half of pi. If you want to write it as pi over 2, I prefer to write it as pi over 2, but if you want to write it as half of pi, that's fine. That's pi. That's 3 pi over 2, or if you want to write it as 3 halves with a pi on the side, or 1.5 with a pi on the side, all those are valid to help with like how we're going to, okay. And then 1 revolution is 2 pi. Okay, don't worry, we're almost done. So pi over 3, is pi over 3, what quadrant is pi over 3 in, or 1/3 pi? Is 1/3 pi more than half a pi? Oh, it is? It's more than half? 1/3 pi is, no, it's okay, it's a safe space. 1/3 pi is less than half a pi, so I'm going to be in quadrant 1 because I'm between 0 and half a pi. So here it is, I'm going to exaggerate quadrant 1, and I'm going to write 2 pi over 3 like this, and here's 2 pi over 3. Theta equals 2 pi over 3. My reference angle is this guy right here in orange. It's the same, so it's in quadrant 1. It's acute, 2 pi over 3 is acute. I'm done. We're good. Are we okay?
Wait, pi over 3 or 2 pi?
You can say 2/3 pi, or you can say 2 pi over 3. Oh, pi over 3. Yeah, pi over 3. I'm sorry, guys. It's been a long day. Thank you, miss. See, you're on it. I'm not on it. I'm going to erase that on my video so it looks like I never made that mistake. I'll leave it. I can't believe I did that. Okay. Pi over 3. Have I messed anyone up? Are we okay? Oh, okay. We're not okay? Are we okay? Okay. I thought I heard you say no. Okay. Ms. Judkins, are you okay? Oh, yeah. You're the one that told me about the error. Okay. All right. Here we go. I'm going to make sure to pay extra attention to not make another mistake. 2 pi over 3. Is 2/3 of pi bigger than a half a pi?
Yes.
But is it bigger than a whole pi?
No.
So what quadrant am I in?
6.
I'm in quadrant 2. So I'm going to exaggerate quadrant 2. Here's quadrant 2. And I'm going to say that here's 2 pi over 3. Theta equals 2 pi over 3. Okay, now that's correct. My reference angle is this one right here. Let me put pi here. Now I'm going to go slow. I don't want to make a mistake again. Should I use this TV or should I use that TV? This one, since I'm already here. You see how I have a pi right here, guys? I don't know if you guys can see from over there. Next time I go over there. I already have 2/3 of pi right there. So what do you think this blank space is that when I add that blank space to that 2/3 pi and that pi? 1/3 pi. Pi over 3. So this right here is pi over 3. Did that make sense? Okay. So now let's go to 4 pi over 3. Look at that 4/3. Is that 4/3? Hit me, miss, hit me. Oh, are you sure? Okay. So look at the 4/3. Is 4/3 larger than a whole? Okay, but is it bigger than 1.5 pi or smaller than 1.5? Yeah, 4/3 is 1.33. So it is smaller. So it's going to be like right here. So there it is. That is 4 pi over 3. Remember, this is pi right here. Intuitively, you probably already know what that is. I'm going to go to this one now because I've been going to that one all this time. Is it okay if I go here yet? Okay, yeah, I'm looking at her. Okay. All right, look at this gap right here. Remember that this is pi. You could have done, so that pi, to help you out, I could have rewritten that pi as 3 pi over 3. 3 pi over 3 is still pi, right? So 3 pi over 3 plus what will give me 4 pi over 3? Yeah, 1/3 pi, or 1 pi over 3. So this is pi over 3 again. That's your reference. Is that making sense, guys? Okay. What do you think? Are you entertained or you're not entertained? Is it too easy for you? You're like, man, I already know this. All right, here we go. I'm going to do a full revolution to 5. Oh, man, I gave the answer. 5/3 pi. Where quadrant is that? In quadrant 4, because you are so close to 2 pi. There it is. Look at that. Not drawn to scale. If that 5 in the numerator would have been a 6, 6 pi over 3 would have been 2 pi. So that means this gap is how much? 1 pi over 3, or 1/3 pi. Does that make sense? Okay. What do you think, Ms. Yoshitsu? You're not entertained?
No, I am.
No. Too easy?
No, I don't understand.
No, you're good, miss. I'm sorry. It's because when I see this, I'm like, maybe it's too easy. Maybe I should like ramp it up. 11 pi over 6. Look how close you are to 2 pi. I am in quadrant 4 for sure. Right there. Finally, we got a number besides pi over 3. If the numerator was a 12, so 12 pi over 6, that would have been 2 pi. So what do you think this reference angle is? 1 pi over 6, or 1/6 pi, or pi over 6, however you say it. Is this getting easier, guys? Okay. I think we got it, guys. I think we got it. All right. Don't worry. We're going to do some together. We're going to let you guys choose 3 problems. We'll probably do 5 total. So look at let's convert these. These are pretty straightforward to do. So 495, that's a degree. It says convert the following angles from degrees to radians. So this is your answer in simplest form. So we're going to leave the pi alone. So 495, what did our notes say? When we have a degree, we got to do what? Multiply by pi over 180. So you're going to go times pi over 180. So how would I do that? I would just take my calculator. I mean, there is a way that you can reduce it as well, right? Without a calculator. But so here it is. I'm going to go, what was it? 495? I'm just going to go 495 divided by 180. Leave the pi alone. I think this calculator is smart enough to do it. Let's see. There it is. Put the pi in the numerator. 11 pi over 4. Let me try it with a pi over 180. See if the calculator would do it. I think this calculator would do it. 495 times 180 over pi. Oh, no, pi over 180. Pi over 180. Yeah, this one does it. This is a smart enough calculator. Not all calculators can do that, but this one can. I don't think Desmos can do that. Or maybe it can, because it just started recently. 720 degrees. I think that one you guys can do pretty easily. Do you guys ever watch the X Games on ESPN? No? When a skateboard dude or dudette does a spin and does 2 revolutions, what do they call that? Oh, they just did a 720. You guys don't watch that? You guys ever like just go to the park and go skating? I don't do it anymore because I'm too old. But when I was younger, like I would skate. You guys don't like skating? Oh, okay. Well, never mind. Okay. So 720 degrees. You're gonna multiply the 720 by pi over 180. 180 goes into 720. 18 goes into 72 4 times. So this is gonna go to 4 pi. And if you think about it, 720 is 2 revolutions. 1 revolution is 2 pi radians. So yeah, 4 pi radians. Cool, right? Okay. The 60 degrees. This one you don't need a calculator. Or maybe you do if you want to. 6 goes into 18 how many times? 3. So put pi over 3. Done. Don't worry, guys. We're almost done. I'm going to bring a fan because it is kind of warm. Or at least I think it feels warm. 165 times pi over 180. I'm going to take my calculator. I'm just going to go 165 times pi over 180. And 11 pi over 12. I'm going to take symmetry, number symmetry, not graphical symmetry. Sean, what are you talking about? I'm trying to expand y'all's brain, guys, so you guys don't become robots. 165 is 15 degrees away from 180. Yes or no?
Yes.
195 is also 15 degrees away from 180. Yes or no?
Yes.
So if 165 degrees was 11 pi over 12, take a guess for what 195 is. No, not 11, but the number still stays 12. 13, using symmetry. So 13 pi over 12. Do you guys see how we did it?
Yeah.
And if you were to take your calculator and you were to tell it 195 times that, it would tell you that. 185 times pi over 180. And bam. Look, 13 pi over 12. Cool, right? You guys knew that though. Or if you didn't know it, you had it like, what's that word? Intuition? Like intuition. Your intuition would have led you there. So all you got to do is just do a whole bunch of your intuition. Wait, is that even how you say it? I can't speak English and I can't speak Spanish. Whatever that word is there, do a whole bunch of this and your intuition will start getting better. I don't even know if I'm using that word right, but there it is. 120 degrees. I'm going to multiply this by pi over 180. I think I'm thinking of like the greatest common factor, greatest common number that goes into both 12 and 18. 6 goes into 12 twice. 6 goes into 18 3 times. So this is 2 pi over 3. How do we feel? Okay. All right, guys. Take a 30-second break. Go to the back of this page. Pick one from 11 through, we're going to do degrees first because that's what you guys are comfortable with. 11 through 16. Pick one of those. Any one.
15.
What? 15? Okay. So 15. So all we got, it says here, what are the directions? Sketch the angle in center position, mark the reference angle, and find its measure. Okay, don't worry, we're almost done. So 15, that says 154 degrees. So here it is. I'm going to do my little grid. 0 degrees, negative 90 degrees, negative 180 degrees. I'm going clockwise. Negative 270 degrees, and then one full revolution. Negative 360 degrees. Does everyone know how I was able to mark those axes? Okay. Negative 154. What is it? Is between what and what? Negative 90 and negative 180. What quadrant is that? 3. So I'm going to say we're going to go clockwise. Bam, like right there. So there it is. That one in purple, that's a negative 154 degrees. So catch up to there. My reference angle is that ray with this horizontal axis. So my reference angle is this guy right here. I'm just looking for the difference. Can the reference angle be negative? No, it cannot. So just tell me the difference between 180 and 154. I guess technically between negative 180 and negative 154. But tell me the difference. Just a positive value. There it is. So that's my reference. Do you see how we did it? Okay. I don't think you guys will have any issues with degrees. It's the radian one that gives you issues. So you can choose two. So let's start with the first one. Which one do you guys want me to work on? It does not matter to me which one. Number 4?
No,
Number
number 5.
5? Okay, number 5. Everyone look at number 5. You see how it says 39 pi over 20? Look how close that is to 2 pi. If that 39 would have been a 40, 40 divided by 20 is, so 39 pi over 20 is in what quadrant? So I'm going to exaggerate quadrant 4. Chop, how come you didn't do it like this one? Because in this one, this was new, so I just, but now we're definitive, so I'm gonna make that quadrant 4 there. So here it is. That's 0. Here's pi over 2. You don't have to write that down. That's pi. That's 3 pi over 2, and then that's 2 pi right here. So here we go. Counterclockwise. Bam, like that, and it's super close to the x-axis. It does not have to be to scale. There it is, 39 pi over 20. So finish there, and then we'll talk about the reference angle. Here's my reference angle right here in red. What is that reference angle? Yeah, 1/20th of pi, or 1 pi over 20, or however you want to think about it. And there it is, guys. Let's do one more together as a group, and then we'll set you guys loose. Number 9. Yeah, we can do number 9. You guys ready? All right. Focus on the 25 over 17. Yeah, this one I'm going to do it like this. 0, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. This one's actually really close. 25 over 17. Let me see. Is there any hacks? I would probably take a calculator because that one's really close. It's actually smaller than 1.5, but that takes experience. This is negative 1.5 pi. Do you guys agree that negative 3 pi over 2 is negative 1.5 pi? So I'm going to do that. Chop, why are you doing that? Because look, I'm going to take that 25 over 17 and I'm just going to type it in my calculator like this. 25 over 17. I want to see what this number is. And I'm going to push enter and look what you get. 1.47. Remember, there's a pi next to it. So it's 1.47, all that with a pi next to it. So that means I'm not bigger than 1.5 pi. So you're going to go clockwise. What quadrant am I going to land in? Quadrant 2. Was that quadrant, right? Yeah. Sorry, I thought I heard someone say, I thought it was like a yawn with a, okay. Yes.
So we don't count them backwards as negative?
Oh, no, I am. I'm going clockwise. So anytime it's negative, you go clockwise. If it would have been bigger than 1.5, I would have passed the 1.5. You know what I mean? I didn't confuse anyone, did I? Did I confuse you? Or tell me, miss. It is a safe space.
No,
For sure. Okay. Yes, Schnitz, you okay? For sure. You okay? Valdez, right? Or Valadez? Valdez. Wimberly? Tell me, miss.
Wait, so now that it's negative, even though we're going clockwise, the quadrants are still going.
Oh, the quadrants are always 1, 2, 3, 4.
Okay.
The quadrant numbers don't change. Right. So the quadrants are always 1, 2, 3, 4. All right, here we go. I need my reference angle. This guy right here. That's my reference. How am I going to get it? Chav, I don't know how to get it. Think of that negative pi as negative 17 pi over 17. Isn't that negative pi right there? So think about the difference between 17 and 25. Yep, so there it is. 8 pi over 17. Remember, the reference angle is never negative. Does that make sense? All right, so all it is now, guys, is getting experience. So see if you guys can get experience. And see if you guys can come in tomorrow for arithmetic, 8th or 9th period. You don't have to. You can just watch the video if you want. And we have about, what time do we get out of here? 2:15 or 2:20?
2:15.
2:15? Yeah, 15 minutes. I think we can do some damage. If you're fast enough, we might be able to finish. Some finished. So it's up to you. You can work as a group. It's not a big deal, guys. And we're done. Yeah, go for it.